All right, so here we go. We are doing transformations. It is the last thing before your test. Now, let me make this plain and clear. When is your test?
Tomorrow.
I changed it.
Oh my gosh.
Sorry. Okay, the reason I changed it is because I told you that you would have like 20, 25 minutes, right? It took the whole entire class, all right? So it took the whole entire class, and they didn't have any time. And then I know that some of y'all have to go. I know some of y'all have to go to the dance. Some of y'all want to go to the dance, okay? So anyway, so I decided that tomorrow I'll give you time in class to review and all that kind of stuff. But y'all, at some point, we got to quit being babies, okay? And we're not reviewing in class. So, does everybody understand?
Is our worksheet still due tomorrow?
Huh?
Our worksheet still due tomorrow?
Your worksheet's due Wednesday. Okay, so we're testing Wednesday, Thursday, all right? And then Friday, I'll have something for you to do. I will be out Friday. All right, so here we go. Today, what are we going to talk about? Transformations, okay? So this is actually 2.7, but it's only one example in 2.7. Transformations. You should already know this, okay? But we're going to talk about it. We're going to talk about, yes. We're going to talk about it really, I think it's example 7. That's what I'm trying to look up. Oh, that was a lot. It's not 2 point, is it 2.7? No, it's 2 point, what was the one we skipped? Oh, yeah, it is 2.7, but it's, we only did the absolute values out of that. It's example 5. Okay, it's only example 5. Okay? So, let's talk about first about what you know. Okay, what you know. So y is equal to negative 2 times the absolute value of x minus 3 plus 1. Okay, so let's pretend we're graphing this. All right, it's an absolute value function. What do all absolute value functions look like?
A V.
A V. Okay, so you got a V. Here's the V right here. Okay, so what does this minus sign do to your V?
Makes it open down.
Okay, so now it's opening like this. Do you understand? All right. What about that 2 right there? Okay, so we can't just say it's the slope. I want to know, first of all, I want to know if this 2 has to do with my graph vertically or horizontally. In other words, would he be with a Y or an X?
A Y.
Yeah, he would be with a Y, right? If he's with an X, y'all, he literally has to be in there with an X. He has to be in something with an X. In this case, it will be in the absolute value with an X. It could be just in parentheses with an X. It could be under a square root symbol with an X. But he will be inside something with an X. You won't be saying, oh, I don't know. I wonder if he's with, no, he will be together with the X. Okay? If he's not together with an X, then he's a Y. So this is a vertical. Would it be a vertical stretch or a vertical compression?
Compression.
Compression. Okay, so if you vertically compress something, is it going to get fatter or skinnier? People, please use your common sense. Okay, y'all, look at me. Okay, if someone vertically compressed me, it's kind of what happened, I think. All right, so I'm not skinny. Vertically compress me, what's going to happen to you? You're going to spread out this way. Okay, if somebody stretched me, please, I would like to be 5'6". I would settle for 5'4", but 5'6", 5'8", oh my word. Like to reach something on the second shelf at our house, that would be amazing, all right? I'm getting too old to climb on the counter, okay? So, y'all, listen, did this 2 make the V skinnier or fatter? Y'all, look, if your slope was 1, where it went down 1 and to the right 1 and the left 1, and now it's going down 2 and to the right 1, what happened to that slope? He got skinnier, people. He was just normal. Now he's like this. That's a vertical stretch. Anytime you have a number that's bigger than 1, doesn't that make sense to you that that would be a stretch? He stretched it 2 times. 2 times his height. You see what I'm saying? If somebody stretched me 2 times my height, people, I'd be playing basketball. Okay? And winning. Okay? So, this is a vertical stretch. How would I make it a vertical compression or a vertical shrink?
You do like a number between 1 and 0.
Yeah. A number between 0 and 1. Okay? A number between 0 and 1. Like a fraction, like a half or a fourth, or a decimal point that's less than 1. Okay? Not talking about negative numbers, because the negative is simply a reflection over the x-axis. Alright, he just took that b from opening like this and made him open like this. Okay? So what does that minus 3 do to him? Makes him move to the right 3. Boom. What does that plus 1 do to him? Makes him go up 1. Okay? Very good. So see, you already know about transformation. So let me ask this question, because I had to squelch this rumor this morning. This plus 1, is that my y-intercept? No, people, that is not your y-intercept. Like, no, don't say that. That's not true. Okay? All right. So I'm going to tell you the rules for transformations. Like, people, I'm fixing to lay this out for you. This is like transformation for dummies. Okay? Are you with me? I mean, is that what your notebook should be? Algebra 2 for dummies?
Yes.
People, that's what your notebook should be. All right? Is it a fast and easy explanation of a lesson?
Yes.
It should be. Is it in your own words? I hope so. I hope that if you found a word that worked better for you, you substituted it into my notes. Okay? So, transformations, remember this. Order is important. Okay? Order is important. So the order that I give these to you in is the best order. 2 of them can be interchanged, but 2 cannot be. All right? So I'm always going to do it in this order. Number 1, if you see a negative on front, okay, it's on the what? X or Y?
For a while.
Yeah, you just told me this right here. This 2 was on a Y. That's why we called it a vertical as opposed to a horizontal. Okay? So he is on a Y, not an X. And he reflects. Now look, does my brain say reflects? What does my brain scream? What word right here? Flips. Okay? My brain screams flips, but flips is not appropriate. Okay? So I'm going to use the appropriate vocabulary, because this is the vocabulary you're going to see on any kind of standardized test. So he reflects over the what? Yeah, the x-axis. He's on the y, but he reflects over the x-axis. And we are going to do it first. Notice that was the very first thing that we did on that problem up there. I said, what does this negative do? And you said, makes it up and down. So we made it up and down. Okay? So we're always going to do that first. All right, number 2. If it is with an X, it is what? An X. Yeah. If it is with an X, it is an X. Birds of a feather flock together. Okay? This is why your parents don't want you running around with a bunch of hoodlums, right? Okay? Yeah, because if you're running around with a bunch of hoodlums, even if you're not a hoodlum yet, what are people going to look at you and say? Oh, there's a bunch of hoodlums right there. Okay? So, and even if you join the group of hoodlums to bring them up and make them better, what will happen?
You'll be a hoodlum.
They will bring you down, people. They will bring you down. All right? So if it is with an X, it is an X. Which way does it move? It moves which direction?
Left or right.
Left or right. Okay? Left or right. How does it move?
Opposite.
There you go. Opposite of what you think. Opposite of what you think. Or opposite, could we say opposite of the sign? Could you say that? Maybe somebody else might like it better like that. Okay? Alright, anybody got a question? Is this stuff you already know? Okay. So let's do the next one. What if it's not with an X? It is a what? It's a Y. Okay? If it's not with an X, people, it is a Y. So this is why we don't say that if it's with a Y, it is a Y. Because we solve for Y to graph it. Do you understand what I'm saying? So obviously if you solve for Y, nothing's going to be with them. Okay? So if it's not with an X, it's a Y. Where does it move?
Up and down.
Yeah. He moves up or down. How?
As it is.
Like you think. Okay? Or like the sign. Positive moves up, negative moves down. Everybody okay so far? Okay? Here's the last one. This is probably the most difficult one. Okay? This is the one that, this will mess more kids up than any of them. Alright? So, might there be some on your worksheet? Yes? Will the test be covered in them? No. Might there be one on the test?
Yeah.
Maybe, possibly. Okay, I mean it is PreAP, like, okay. So, this one is if there's a negative on the X. A negative on the X. Now how will I know if it's on the X? It will be inside the absolute value. It will be inside the parentheses. It will be underneath the radical with the X. You see what I'm saying? It will be all of those things. You'll know he's with the X. Where's he going to reflect it over?
The Y.
Yeah. If it's on the Y, it reflects it over the X-axis. So if it's on the X, it's going to reflect it over the Y-axis. When am I going to do it?
What?
Yeah, you're going to do him last. Okay? This one you have to do first, and this one you have to do last. All right, so anybody got a question so far? Everybody okay? All right, so let's take all these and let's apply them.
Is this the
All
third
right.
skill that's on the test?
The what?
When you said the test tomorrow is over 3 skills, is this the third one?
Where have you been? Like, we changed the test. Weren't you here?
No.
We changed the test to Wednesday, Thursday.
Okay.
The
Okay?
worksheet's due
But it is a good question because here's the way it's gonna work. Wednesday, your test will be over piecewise functions and this, transformations. Okay? No calculator, people. Okay? We're fixing to find out who can graph and who can't graph. If you can't graph, you will not pass this test. Okay? And then Thursday will be over regressions. That's where you put it in the calculator and you gotta know how to find the line of best fit, a linear regression, and you gotta find your R squared. Everybody got it? Okay, the worksheets will be due Wednesday. We'll pull out those 2 sheets that had the regression stuff on it, staple it on the back of the other one. All right, so I'm going to take a piece of graph paper, okay? And here's the way the transformations are gonna work. To test your transformations, I'm gonna give you a function, so I'm gonna draw it. It's gonna be a wacky function. Okay? It can look,
Do we draw it too?
yeah, I will. It can look really kind of simple or it can be really crazy. So this is what ours looks like. These are supposed to be straight lines. Okay? All right, so this is f of x, my function. Okay, so we're going to do all kinds of transformations on this function. We're going to do some vertical stretches, maybe some vertical shrinks. We're going to shift it right, shift it left, shift it up, shift it down. We're going to reflect it. We're going to do all those things to it. Okay? So the first thing I want to know is how many points have I specifically labeled on this function?
5.
5. Okay? So if you've looked at your worksheet, you'll know you've seen something like this. Are you with me? Where it just said numbers and then had blanks like this, and you're like, what? What are we supposed to do here? Okay, so, all right. Do you agree that there's an order to listing those points? Does everybody agree with me?
No.
How would you think you would go?
Origin to the farthest?
Yeah, from the left to the right, the same way we read. Do you think we're, like, do we have our cowboy boots on and hats and stuff? We're riding horses, we're gonna round it up? Does that make sense to you? No, that's crazy, people. We're going from left to right, all right? So I'm trying to tell you that I want these points listed in a certain order. I don't want you to be crazy about them. I don't understand why kids go berserk. All right, so what's this point right here? 0, 0. Good job. See, this is not difficult, is it? Okay, what about this point right here? 2, 3. Went right 2, 1, 2, 3. Up 3. Okay, what about this point right here? If this is 2, 3, 4, yeah, and down 2. So 4, -2. It's not as easy when it's up here on the projector, okay? It's a lot more difficult. But when it's on your paper, you can do it. What about this guy? Yeah, 5, -2. He's just one to the right. And then this guy's another one to the right, but he went up 2. So 6, +2. Very good. All right, so is everybody okay? All right, so let's do the first transformation. The first transformation is going to be this. I want to find what is 2 times f of x. Obviously, I'm going to list these points. Okay? Now listen to me. This 2 right here, is he on the x or the y? He's on the y, right? If he were on the x, people, he would be inside there with the x. Okay? So he's on the y. So would that be a vertical what? Yes, a vertical stretch. A vertical stretch. Think about what would this look like if you vertically stretch this thing? See what I'm saying? That's what we're fixing to do. All right, so he's in front. Let's take care of him first. Okay? So 2. What are you doing with that 2? Multiplying by what? Yes, because what is the y right here? F of x. Doesn't that just say 2 times f of x? What is f of x? Y. So you're multiplying 2 times the y value. Are you doing anything to the x value? No. Okay, so look at this point right here. The x value stays the same, 0. The y value, what's 2 times 0?
0.
So here he is. He's just right there on top of that black dot. Okay? All right, let's do this one right here. What's the x value? 2. You don't do anything to it. The y value? 6. 2 times 3 is 6. So this guy right here, instead of being 2, 3, he's 2, 3, 4, 5, 6. Does that look like a vertical stretch? You see how he went up higher? Guess what this guy's going to do? It's going to go down lower. Okay? So what's the x coordinate of this? 4. Okay? What's 2 times -2? -4. So at 1, 2, 3, 4, he's at -4. 1, 2, 3, 4. Look at that. That's a beautiful example of a vertical stretch. Okay? 2 times what he was. What's this guy's x point? What's his y point? -4. 2 times -2 is -4. Oh, he's right there by his buddy where he was. I like that. Okay? What's going to happen to this guy? It's going to go up higher. He stretched it. So what's his x coordinate? 2 times 2 is 4. So he's at 6, 2, 4. Does that look like a vertical stretch?
Yes.
Perfect. It's amazing. All right, let's do the next one. All right. Boy, I'm going to jump out here on this one. So y is equal to negative f of x minus 2 minus 5. So I'm going to put my points like this. Okay? All right, let's go by your rules. Okay? What's the rules say? What's the first thing you have to address in this right here?
Parentheses? Oh, no.
What's the rule number 1 say? Anything on front? Is there anything on the front? Got a big negative sign. Did we address anything on front here first? Yeah, we did. Okay, so negative. So what does this negative do to it? What is your Okay, yes, except I'm gonna go more by what your directions say, but you're headed in the easiest direction, and I like that. Okay? So what does your direction say? It says it does what to it? Reflects it over the x-axis. Okay? Y'all listen to me. If I take this point and I reflect it over the x-axis, do y'all know how to reflect over the x-axis? It's like if you fold it on the x-axis, where would it land? Y'all, would this point move anywhere?
No.
He's not moving anywhere, okay? He's on the axis, all right? So what does this minus 2 do to that point?
Move it to the right.
Moves it to the right 2. So I go 1, 2. I'm right here. Are you with me? What does this minus 5 do to this point?
Bring it down.
1, 2, 3, 4, 5. So that's the new point, okay? That's the new point. Now let's do this point right here. First thing I do, reflect it over the x-axis. Do y'all know how to do that? If you folded this on the x-axis, this point would land down here. Do you agree? How many down here? 3. If it took me 1, 2, 3 steps to get to the x-axis, it takes me 1, 2, 3 steps to get away. So I'm right here. Now what does the minus 2 do to it?
Goes right.
1, 2. What does the minus 5 do to it?
Bring it down 5.
1, 2, 3, 4, 5. All right, now let's think about this, because this line is this little line right here. Do you agree with that? Okay, does he look like he's about the same length? Yeah, because look, you had no vertical stretch or anything, so he should look fairly the same. All right, but has he shifted to the right and then down? To the right and then down? Has he reflected? Yes, because this point right here is now this point down here. Instead of going up, he's going down. Are you with me? Okay, so let's do this point right here. Reflecting over the x-axis. You know where he is? Yes? 2 to get to the axis and 2 to get away. He's right here. Now what does this do to him?
Goes right 2.
Right 2. 1, 2. He's right there. I didn't mean to make that dot. I don't know if I can do it left-handed. Wow, so talented. Okay, what does this minus 5 do to him? 1, 2, 3, 4, 5. So he's right here. I gotta do that again. That's right. So there he is. You got him? Okay. What about this guy right here? Reflect him over the x-axis. 2 to get to the axis. 2 to get away. Now what do I do to him? To the right 2. 1, 2. And down 5. 1, 2, 3, 4, 5. Ooh, I'm so smart. It's right beside his buddy. Okay. What about this last point? Is he going to be up here or down here? Down. He reflected him, y'all. He flipped him. Okay? So now instead of him going up to that point, he's going to go down to that point. Okay? So I'll reflect him over the axis. 2 to get to the axis and 2 to get away. I'll go right 2, 1, 2, and down 5. 1, 2, 3, 4, 5. Perfect. You see it? You see how they took this thing right here? They flipped it upside down, so the point's on the bottom and the flat part's on the top. And then they shifted it right 2 and down 5. And there he is. Okay? Let's figure out what his points are. This point right here is 2, negative 1, negative 2, negative 3, negative 4, 2, negative 5. Are you with me? Yes or no? Yes? What about this point right here? If this is 2, this is 4, here's negative 5, so 6, 7, 8. So 4, negative 8, is that right? This guy right here, so let's count him. 1, 2, 3, 4, 5, 6, negative 3.
And then 7, negative 3.
And then 7, negative 3. Because he's right beside him. Okay? He's just to the right one. Now this is right another one. So he's what? 8. And there's negative 3. So this is negative 4, negative 5, negative 6, negative 7. That's negative 8. It's up 1. So negative 7. That looks good. Alright. Was that difficult? Okay. Does anybody see how I could mathematically do that?
What do you mean?
Instead of just going by looks and moving it all over. Could I take, okay, now I'm gonna cover up the pink because one of the most common mistakes is when I'm trying to get these points to look at the guy above him. No, they did not come from those points, they came from the black points, okay? From the original graph. So, can you look at this equation and figure out how these points get to right here? Andy?
Add the 1 to the x and subtract the 5 to the y.
Okay, but before you subtract the 1 from the 5 from the y, what do you have to do to them?
Flip it.
Yeah, you gotta multiply by that negative 1. Okay, so watch this, guys. I'm gonna show you another way to do it. Look, if you like the way that is, that's perfectly fine. There's nothing wrong with it. It does get confusing. You are counting squares. It's easy to make careless mistakes. This is math, people. I like to start with the x's because the x's are so easy and they're so straightforward. All right? If they say minus 2, you really went where?
Right.
To the right 2. What is that really? Plus 2. So if I take each one of these x values and add 2, I should get this. Do you agree? What's 0 plus 2? What's 2 plus 2? What's 4 plus 2? What's 5 plus 2? What's 6 plus 2? Bam! People, out of those 5 points, or those 10 numbers, I just got half of them. Do you understand? I got 1, 2, 3, 4, 5 points on my paper. Okay? Now, let's see if we can get the y's. The y's are the most difficult. So, remember you have to do this guy first. So the first thing you do is you take this y and you multiply by this number. So, I want negative 1 times 0. And then what am I going to do? Subtract 5. What is negative 1 times 0? What's 0 minus 5? I'm going to say negative 1 times 3 minus 5. What is negative 1 times 3? What's negative 3 minus 5? Right here, I'm going to say negative 1 times negative 2 minus 5. What's negative 1 times negative 2? 2 minus 5. Negative 3. I'm going to do this one again. You should be the same as this guy. So I'm going to say negative 1 times negative 2 minus 5. Negative 1 times negative 2 is 2, and 2 minus 5 is negative 3. I'll do this guy. Negative 1 times 2 minus 5 is negative 2 minus 5, and there's my negative 7.
Can't you just change the sign?
Yes.
Instead of right?
Yes. But here's what I want you to understand. If this had been negative 3, could you have just changed the sign? You would have had to multiply by negative 3. You understand? Okay, so I taught you a skill rather than just how to finagle something. Okay? All right, you ready for the next one? Which one do you like better? The math part. Most people like the math part better because it's very straightforward. Okay? I mean, there's nothing wrong with looking at it and physically moving points. Okay? But it is easy to get messed up. All right, so here's yours. I'm going to let you do it. Are you ready? I'll tell you what I'll do. I'll let you find the first 2 points first. Okay? And then we'll check them and make sure they're right. I'm going to move this guy up some because last time I ran out of it. So, y is equal to,
Can we do it on the same graph or what?
yes, 2f of x plus 3 minus 1. We're finding the same 5 points that have had that transformation on them. Okay? Now, if I do it, if I look like this, when I start to look up at the points, what's screaming my name? Which points? The blue guys? Okay? People, we're not looking at the blue guys. Okay? We're not looking at the blue guys. The only guys you're looking at are the original function. Okay? So you see if you can do the first one and the second one. Who did I say do first? Because they're so easy. X's. X's are weird. What do they always do? The opposite of what you think. The opposite of what their sign is. Okay, so my first X, did y'all get -3? My second X, did you get -1? Okay, if I were you, what would we do right now?
Write all the X's.
Yes, people, like it's in your head, go do it. Do it fast, all right? It's stuck in your head, so go and do it. Then we'll change. All right, is that what y'all got?
Yep.
1, 2, and 3 after that? Okay, so now let's do the Y's. The Y's are more, they're probably a little more involved. You gotta take care of this number out front. When do you do that? Yeah, first. It says, do this first, okay? And then we'll do this, and he is exactly what he says he is. He's -1, okay? So I'm only messing with the Y's. So I start off with my 0, and I'll go 2 times 0 -1. Now what's gonna be the common mistake right here? You're gonna say 2. Y'all be careful about that. You're not going to have a calculator. You cannot rely on a calculator. You gotta say stuff out loud in your head.
Why would it be
Okay?
2?
It's not 2, but that's a common mistake. Because listen to me, if I say 2 times 0 is 2, and I say that out loud in my head, my brain goes, whoa, what? What'd you say? Okay? So, what is 2 times 0? 0 minus 1? -1. Okay? Let's do this guy right here. Are you with me? All right, I'm going to start here, 3. All right, I'm going to say 2 times 3, right there, -1. 2 times 3 is 6. What's 6 minus 1? I'm going to do this guy. He's -2. So I'm going to say 2 times -2 minus 1. What's 2 times -2? -4 minus 1? All right, let's do this guy. He's -2 again. He should be the same as this one because they're right beside each other. Okay, I noticed that visually my brain went, oh, these are right beside each other. Okay, so 2 times -2 minus 1. -4 minus 1. There's that -5 again. Feeling really smart. Go up here and do the 2. 2 times 2 minus 1. What's 2 times 2? 4 minus 1. All right, anybody got a question? Is everybody okay? Okay, so let's do one more. All right, this one's going to be a doozy. All right, so y is equal to f of, what am I fixing to do?
Put a fraction.
No. Fractions would be too hard for me to grade. I don't want to do that. Where am I going to put my negative? On my x. Do not look at the purple guys. Do not look at the purple guys. You always go back to that original function. Go back to the black function. I did them all in different colors so they'll be easy. How about you do the first 2 points, and then we'll see how good you are. On this one right here, who's the easiest one, the x or the y? The y. Remember what the x is going to do. When am I going to apply this negative? The end. It's going to be the last thing. So you're going to say x what?
No,
Minus 1, and then you're going to take the opposite of it. Okay?
Wait, what?
See, he's the last. See what your directions say? Let me find them.
Reflect over y.
Yeah, reflect over the y-axis. you're gonna do this last, okay? You're gonna do that last. So, I still have to go, there's my x, 0, okay, so I'll still go 0. I mean, y'all, he's still with an x. He still does the opposite of what you think, okay? So he still goes -1, but once I get that answer, I'm gonna take the opposite of it. So, yeah, what is 0 minus 1?
Negative 1,
What's the opposite of -1?
1.
1. Okay, look at the y's. There's nothing out front, guys. Okay, all you're doing is minus and 2. So there's my y, 0. So I'll go 0 minus 2 is what?
-2.
Do the same thing for these x's. I'm gonna say, this one's a 2. 2 minus 1, and then change its sign. That's what that does. Change his sign. Last. What's 2 minus 1? What's the opposite of 1? My y's, 3 minus 2. What's 3 minus 2? Okay, you see if you can do those 3. Is that what y'all got? -3, -4? -4, -4? Right beside him. Gonna be kind of patterns here, okay? Especially if you do the same function all the time. One went over. All right, anybody got a question? Which way you like it? Mathematically? Or doing pictures and moving? Yeah, most people do. But some kids still are like, nope, I like it the other way. I like it the other way. All right, so before you say this, okay, because this is always what every kid says now. Yeah, right. When are we gonna ever use that, Miss Davis? That's crazy. So let me show you. You do not have to write this down, okay? This is a teaser for what we have to look forward to. Okay, so first of all, y is equal to the square root of x. If you did the optional project, then you know what this looks like, right? It's the top part of a sideways parabola. So let me show you what it looks like. Let's plug some points in. Can I use any negative points for x? No, you can't take the square root of a negative number. We'll learn how in chapter 4, but we're not now. All right, so we're only going to use positive. So what about 0? Can I take the square root of 0? What is it? 0. Okay, what about 1? What's the square root of 1?
1.
All right, so 1, 1. I don't like 2s and 3s because they're decimals. What about 4? What's the square root of 4?
2.
2. Okay, obviously out here at 9 somewhere, it's going to be up there at 3. So here he is like this. Are you with me? You see what I'm saying? Like the top half of a sideways parabola? Okay, so what if I did this to my parabola? What if I said y is equal to 2 times the absolute value of x minus 3 plus 1? Okay, so first of all, what does this 2 do to this parabola? It's a what? What do we call it? Is it vertical or horizontal? Is he with an X or a Y? He's with a Y, so that's vertical. The X-axis runs up and down, that's vertical. Okay? the y-axis runs up and down, that's vertical. The x-axis runs horizontal. So anything with an x would be a horizontal something, okay? And just so you know, they'll be just the opposite of what you think. So like on a horizontal, this number 2 makes it a vertical what? Stretch. On a horizontal, it would make it a horizontal shrink. They do just the opposite of what you think. All right? So this is so this 2 is going to take this graph and it's going to stretch it up like that. So he's going to be taller. Okay? What's this minus 3 going to do to him? Right 3. 1, 2, 3. What's this plus 1 going to do to him? Up 1. So this is that beginning point. My second point did go up 1 and to the right 1, but it had a vertical stretch of 2. So now I'm going to go up 2 and to the right 1. And he's going to look like this. See how much taller he is? Okay? What if I did this to him? What if I said y is equal to negative 2 times the square root of x minus 3 plus 1? What's that negative going to do to this graph? Yeah. He's going to make him go down. And he's going to look like this.
When you have to move that point to?
Move what?
When you have to move that point to?
What point?
The one you just drew off of?
Oh, I used my slope. You can use your slope one time. Okay? So I went down 2 into the right one instead of down 1 into the right one. Okay? What about this guy? Here's the wacky guy, the guy that messes all the kids up. Look at him. I'm going to do him totally different. Okay? And I'm going to draw him with a pencil because I'm kind of like going, I don't know about this guy. He's kind of weird. All right? So what happens to this? Now, when do I do this? Last, people, last. Don't even worry about him right now. Let's just go here. Okay? What does that plus 2 do to it?
You go down.
Left.
No, left.
Yeah.
Left zero.
He's with an X. So I go left 2. What does this minus 3 do?
Down.
1, 2, 3. So this is where he starts. This is that point, up 1 and over 1. So normally he would be looking like this. Do you see him kind of there? It's like a ghostly one. All right? What does this negative do to it? Yeah, he reflects it over the y-axis. So instead of going like this, now that dude's going like this. Okay? This point right here, 2 to get to the axis, 2 to get away. This point right here, 1 to get to the axis, 1 to get away. This is what the function actually looks like. Okay? Kind of weird. Kind of weird. Look at his domain. His domain has almost all negative numbers. Except for these little ones right here. Why? Because when you take the opposite of a negative number, what do you get? But what if I took the opposite of a positive number? Let's do 4. What's the opposite of 4? What's negative 4 plus 2? What's the square root of negative 2? What? You can't take the square root of negative 2. Right? You see what's happening?
It's no solution.
Pretty cool. All right, so the problems on your worksheet are these problems right here, so you can take a picture of them, okay? They are these problems right, here's the directions.
Are they in the book?
Yeah, in the book.
So I'll do it. Oh, can I?
Those right there. Oh, yes. Just sign it out on that sheet, okay? All right, so those are the problems. Notice that these have 3 points, right? What's going to be the very first point you're going to write on your paper? Negative 2, 3. Then don't go down here and write this one, because what will happen is you'll mess them all up. I'll just count them all wrong, because you didn't write them down right. Write them down correctly, people. Left to right. All right, anybody got a question?